Tomorrow will be better. A car corners at 28 meters per second on a curve of radius 380 meters. What is the passenger's acceleration? Dear friends, I know most of us, each time we hear of acceleration, the first thing that comes to mind is Newton's second law. But in this case in particular, there are some keywords to highlight here. Notably, look at this. A curve path, and they're talking about a radius. At this point, another thing should come to mind, which is movement along a curved path. Follow me, dear friends. Solution. Consider the first case of Newton's second law, which says F equals to ma, and you want to get the acceleration from here. You will notice clearly that you don't even have enough information to proceed in this method or with this formula. If you now want to try uniformly accelerated motion and use one of the equations, you'll still notice that you don't still have enough information. All we got here is the velocity here, and then this so-called radius is not even worth considering as a distance because the car is not moving along the radius. The car is moving about the radius, okay? So we can really consider this radius as a distance. The only option here to go about solving this problem is to bring in the idea of centripetal force and centripetal acceleration. Centripetal acceleration is given by v squared all over r. Clearly, all the elements of this formula have clearly been stated in our question, and we can therefore apply numerically and say v, which is 28, all squared divided by r, which is 380. And if you numerically punch this correctly, then we should be having 2.08 meters per second squared. It's an acceleration difference, and this is how very easy it is. Tomorrow will be better.